Good evening, everybody, and welcome to GlugNet. My name is Stephen Ball. I'm the president. This evening, we are pleased to welcome Al Rodriguez, who will be talking to us about setting up a C# pit of success. Additionally, we are pleased to welcome back Matthew Hess, who has a lightning talk for us on cooperative cancellation. But before we get started, a little bit about us. GlugNet is the Greater Lansing user group for .NET developers. We hold our meetings on the third Thursday of every month. They are free and open to the public to attend. The best way to find out more information about us and what we have coming up is on our meetup page, meetup.com/glugnet. We also have a LinkedIn page as well, where we will announce all of the meetings. So if you're on LinkedIn, please give us a follow there. Recordings of our meetings are typically posted to YouTube by Sam Nasser. You can go to his channel by using the QR code on the screen here, or going to his channel at Sam Nasser MVP on YouTube. A few housekeeping items. We are always looking for lightning talks to happen before our main presentation, like Matthew's tonight. So if you have a 10 to 15 minute topic that you would like to present, please let either myself know or Joe Kunk, and we can get you scheduled. Tonight's presentations are designed to be interactive. We definitely encourage questions or sharing your thoughts on the topic. You can do that by either popping off of mute, or if our speaker has questions for us, feel free to do so and answer. If you are unable to or just not comfortable doing so, you can also use the GoTo chat, and we'll be monitoring that for questions throughout the event. At the conclusion of tonight's presentations, we will have a survey made available to all attendees. In particular, we are looking for feedback on two particular areas. One, how did we do at getting the word out about this event? And two, what did you like about the presentation? What didn't you like? Every bit of feedback received in this survey is anonymous. So please answer good, bad, somewhere in between. We want to hear it all because that's how we grow. I will leave the survey open until Friday at 8 p.m. Eastern time. So you do have a little time to mull it over if you need to. So I would recommend right now, if you've got your phone handy, I'm sure we all do, go ahead and grab that QR code there so you can fill it out. I will also provide a link at the end if you happen to miss this QR code. Our sponsors for tonight, NIS Technologies, who is providing this go-to session for us, and the .NET Foundation for their financial support of GlugNet. And now it is time.
Hey everyone, I'm Matthew. I'm really happy to be back. Thank you all for allowing me to come back yet again. It's good to see some friendly faces and names. If you're not sick of me by now and you're interested in getting in touch and finding more content, oh, that screenshot has, well, it might, that QR code might work. You can find me on LinkedIn at Matthew L. Hess. You can find me on YouTube at C# Artisan. Got a whole bunch of videos there. It would be lovely if some of you would watch them and subscribe. And you can email me, csharpartisan@gmail. The lightning talk, so let's get moving. We're going to be talking about cooperative cancellation. And I know that sort of sounds like you and a bunch of your friends were planning to go get a beer and you all got together and decided not to go. That was cooperative cancellation. And it's similar to that. Okay, it's a C-sharpy way of kind of doing that. So what is cooperative cancellation? Cooperative cancellation happens when you have a long-running process or processes, such as a thread or a task, and you want to tell it to please stop what it's doing. Just stop. Don't finish. Don't keep chugging. Please just stop. And you want to do it politely, but definitively, so that you can gracefully shut down a background process or a series of threads It's the software equivalent of clicking start, shut down, and closing the windows as opposed to just popping out the battery and pulling the plug on your laptop and just cold booting it. So I don't think you can pop the batteries out anymore, holding down the power key or whatever we have to do these days to do a really abrupt shutdown. So that's the problem we're solving. And you can hand roll this. And I've got a little video where we kind of talk about that. But what I'm going to show you today is kind of the standard C# approach to this using a cancellation token. And so the first example we're going to look at is a cancelable task, a simple cancelable task. Now, this task has in its heart a long-running loop, a while loop. And so here's what the code looks like, right? Public async static task execute. And we just pass in an ID so we can identify it in the log messages. And then we pass in a cancellation token. And now we get some logging, and we go into this long running loop, which basically means do this forever until I get this signal from the cancellation token that cancellation has been requested. And then because of the way this is written, it will just drop out of the loop and it will stop executing. So there's an example of a task wrapping a long-running loop that is cancelable. We're going to run that code here in just a second using this program. And all of my little sample programs kind of look the same. I'll just execute it. And what you can see is we have a little menu of things we can do. And the first item, if we select one, it's actually going to run a cancelable task. So I'm going to select one. And now it has started, and you can see it's looping. Every second, that while loop is just looping. There we go. Long-running task. And when we are ready to cancel it, I'm going to click enter, and this is going to signal it to stop. Are you ready? And there we go. So it stopped. We shut down our loop. So let's look at the code inside my program that does that, because when we select item one, we run this one, run cancelable task. So we create a cancellation token source. And here we are launching the task. And the little message, press enter to cancel it. And once you hit enter, this line executes, cancellation token source dot cancel. And that sets that flag. Easy peasy. There you go. Cooperative cancellation. Now, one thing you'll notice in that particular example with a loop is that it does have to complete the current loop. So if I select one and cancel right after, well, it's hard to illustrate it unless I really lengthen the time of the loop. I guess I could do that, and to really make this clear. So let's let it pause for 3 seconds. Okay, we'll bring this over. Okay, so now we have these slower loops, and I'll wait till it gets into loop 3 and hit enter. And did you see how the stop execute waited a couple of seconds? So that's just one thing to be aware of in this kind of polling loop where the way it's constructed. There are ways around that, and we're going to talk about that. And there are other constructs like event wait handles and other things that can give you instantaneous stoppage. But depending on how you've done this, there might be just a little delay. So the next example is run several cancelable tasks. All it does, number 2, is it just starts 3 of these. So now they're all going to loop. I've got them staggered by a quarter second. So now they're all looping. And I hit enter, and they all stop. And what's nice about that is when we look at the kind of the control code there, is when we're running several, we stop them all with the same cancellation token source. right? So you've got one master kill switch for everything. So that's nice. You don't have to like go through and like stop them all. Okay, so the next example of a cancelable task is one that is wrapping an HTTP call. We're actually calling, we're going to call HTTP client get async. So many of the .NET, of the async methods that are given to you through .NET libraries and NuGet packages, whether you're talking about the HTTP client or service bus or the SQL async methods, many of them have an override, a method signature that includes an optional cancellation token that you can pass in. So that means that what will happen here is not only will sort of our master function inside this task cancel if there's something that needs to, but it can pass it on. It can basically forward the stop signal to anything it happens to be awaiting. So this particular Azure function that I'm going to call, it's a little Azure function app that I have loaded up, and all its purpose is to delay. Like you pass it a parameter of delay sex, and it just doesn't return your HTTP call until it's done. So that's its mission in life. So what's going to happen here is when we call await client get async, this should await for 10 seconds before we get that log message. And what I'm going to do is I'm going to cancel it before the 10 seconds are up. So we'll run this code, and we're going to launch this long-running HTTP call. And before 10 seconds are up, boom, cancels immediately. Okay, so the await, which that's a whole other topic about how async await works and how it gets your signal, but that method supports the concept of using the cancellation token just to cut off anything that's awaiting, no matter where it is in its await, whatever's going on. So here is the the control code for that. Very simple. We launch the task and it's the same, and we just say cancellation token source dot cancel. And the next little demo is to have 4 of those going. So, oops, you guys can't see my other screen, but there we go. So I've launched those. I will hit enter before 10 seconds, and all of them canceled. Just stopped on a dime. The last example I'm going to show you of using cooperative cancellation is with a thread. Now, thread-based programming has gone a little out of fashion, and in fairness, tasks do almost everything that native kind of C# threads can do. So for the most part, there's no reason, many of us don't have a reason anymore to implement threads. But if you're building your own like web server or something, kind of a framework, there are some things to be said for actually spooling up your own dedicated threads and just managing their full life cycles explicitly rather than through the task programming model execution kind of framework. So here is a cancelable thread. So if you're going to run a thread, basically you need to define a thread proc. Like, what is the loop? What is your thread proc? So here it is, and it's just called run. And you're going to have to call a delegate or pass in a delegate. So this delegate for running a thread can accept an object as its input. This is like C# 2. This is very early C#. So inside of this is where the actual thread loop is. And this is the thread loop, the long-running loop. Now, in order to pass data to a thread, it is traditional to create a little class, which is the data that your thread wants on the input. So I'm just calling that thread start data. Our thread starts running and it casts the object to the proper type. And then it drops into a long-running loop, which pauses for 1 second in the middle, and which will break once the cancellation is requested. So threading is fun. I actually have like a 10 video series on threading and tasks and background worker and just lots of different ways of approaching parallel programming. So if that's of interest to you, you can go find those videos. But for now, let's just run this little demo. So we're going to run a cancelable thread. And there it is. The thread is running and it's looping every second. And if I press enter, my thread will stop. And we can do number 6, which starts 3 threads. So there we have 3 threads looping. And whenever we feel like we've had enough of them, we press enter and they all stop. So there you go. Cooperative cancellation. It's something that you may have seen and wondered about. It's a really useful technique. And now you've seen it in action. Before we hand it over for our main presenter, any questions on that? We have like a minute.
No, no questions, but very cool. I didn't know that
Right on.
existed.
Okay.
All right, thank you, Matthew. Okay, Al, you're up.
Hey, awesome. Let's see, I should probably start moving some other things around on my monitor. Sorry, I don't think you can see any of that stuff I just moved. Okay. Uh, so, first of all, that was an awesome lightning session. That was great. I learned a lot more about cancellation tokens than I thought I knew. So cool. All right, so hey everyone, welcome to this session on setting up C# bit of success. So a couple of things. To those of you who are watching live, I've already put a link directly to the slides in the chat. I've also put that same link in the meetup page over here, so you can just kind of scroll down and the direct link is there. So that link actually goes directly to my personal site, programmeral.com. I've made a page specifically for this, and so there's going to be some demo code that I'll show. So that's this first button right here on the left, and the one to the right is to view the slides directly in your browser, which is where I'm hosting them from for this talk. So you can go ahead and see them exactly the way that I'm presenting right now, or just rewatch the recording. That works too. Yep. So cool. Yeah, I guess we'll go ahead and start the actual session. So, the purpose of this is to really discuss, what exactly is a C# bit of success, or what is a bit of success just in general, and then how do we go ahead and set that up within C# projects, right? C#.net, all of that stuff. Everything I'm saying right here, these are all recommendations. You don't have to use these. I'm not saying if you don't use this, your code is bad. No, I just, we're all adults. We all have our general ideas of what works for our applications, and our applications are all different too, right? Some of these things that I'm saying might not work at all for a specific type of application. So yeah, use whatever works. Everything that I'm going to mention here is free. There's a little asterisk in that slide, or in that little section right there, just because one of them isn't free. There's some license stuff right at the end. I'll call it out. But everything else, the majority of things that I'm going to mention here, are free, all built into the .NET platform for us, which is great, right? You don't have to go and start asking for, for someone within the company to go ahead and buy licenses or something. That's awesome. Before we go through it, people always tell me I apparently when I talk I have to talk about myself, which I don't like. So 10 seconds here. My name's Al Rodriguez. I capitalize both letters because if not, people call me AI. It has been happening for a few years. I get the feeling this is something I'm stuck with for the rest of my life. But I've tried to take the name Programmer Al everywhere, and you've already seen the blog link right there. But LinkedIn and Blue Sky are the two main social media that I use. So if you want to just go ahead and search for me on either of those, I usually tend to just auto approve whoever wants to connect on LinkedIn, that kind of stuff, all that. So all right, back at this. Cool. So what does a bit of success get us, right? Like what's the point, before we start talking about it, like why do we want this in there? And we want this in our code for a couple of reasons, right? Guardrails, uniformity, right? We want our code to kind of be safe. We want to be able to add code without worrying about horrible issues down the line, or in an hour, right? We want code uniformity in that we want code to look similar, right? If I'm a developer on a team writing some code and another teammate over here is writing some code, we don't want the way that we create solutions to be very different, because then when we have a third person go ahead and join the team, they're going to be confused. Like, hey, what's the standard process, right? But the last one, the one that I think is most important, the biggest reason, is shifting work left. And whenever you shift left, the downside to that is always, well, now we have to do a lot more work now. We have to think through this more now, right? More edge cases and just normal cases too, right? So that's the hard part. That is the annoying part, I guess, of shifting left. But the good thing is that more work now means a lot less work later. And so that's part of the pit of success. If we set that up, we're thinking about that stuff right now, like all of these potential cases, and then there's less of that murky stuff we have to deal with within our code later on. So that's the big set of benefits. And so as far as this session goes, like I've kind of already said, everything I'm saying here, this is just a set of recommendations. I'm going to show off some demo code that has everything set and enabled. I'll show off a couple examples of what happens when you don't use those things. But for the most part, these are recommendations. You don't have to use them. If you want to yell at me on social media after this, again, Blue Sky or LinkedIn, feel free. Go for it. Have at it. If you're watching live, I mean, don't be rude, but yeah, if you want to call something out, feel free. Sure, why not? Just, whatever you think is best. All right, so let's start with the first recommendation, I guess. It is what I call strict mode in C#. It's treat your warnings as errors. So if you're not familiar with this is just a simple compiler flag that you can go ahead and enable to say, hey, I have a bunch of compiler, anytime you see a warning, just make it an error. Don't tell me about anything being a warning. If I have a warning, don't compile, right? That's it. That's the strict mode. And pros and cons to that, right? Again, it goes back to that shift left thing of, we have to do more work now. Like as we're typing out that code, we have to do more work now. But that means that we don't leave something in our code that is an issue, right? A warning later on. And so I can show a quick example right here within some demo code. So this is an ASP.NET application. And we have a couple of things. We'll talk about them later, but this one right here, this treat warnings as errors, that's all you have to do. You just have to come in here, turn it on. You either type this out, or if you're using, Visual Studio, Writer, VS Code, whatever, like they all have a UI to go ahead and enable it. But that's all you have to do, and now all of your warnings instantly become errors. Now, you're probably thinking, but my application has 200 warnings. Well, that's a problem, right? Some of those 200 might be an actual problem that you will have to someday deal with within your code. And if you treat them as errors, then they never will have become a problem, right? So in that case, the thing that I like to say is, once a sprint, make a task where, you time box it. Some developer on the team gets to spend 2 hours just fixing as many as they can. Next sprint, someone else gets to spend 2 hours fixing them as many as they can. And hopefully you don't spend a lot of sprints doing that, right? And also hopefully you're not adding more warnings as time goes on. But then eventually, once you get down to 0, then you can go in and enable this flag. And there you go. Now you can, moving forward, you can have a much cleaner set of code. And so I do want to call out that other later recommendations, other things we're going to talk about, kind of build on this. Not explicitly, but I think that these other features are better when this is enabled, when you are treating all of your warnings as errors. This is something that I've been doing personally for probably 6 years at this point. And I've been doing this on new projects, when possible. I do this at my current job at work right now. We like it. It's nice. I am going to talk about some of the other errors that can pop up a little bit later, because maybe you don't agree with all the warnings or errors, right? That could be another question, but we'll talk about that one in a few slides. But I already showed you how to do this. That's it. It's just a one-liner. Really simple thing. All right, here's the next recommendation, nullable reference types. So this is the one that when I say it, I think a lot of people, if you know what nullable reference types are, either you are very much for them or very much against them. Most people are against them. I think they're great. I love them. This is probably my favorite feature in C# ever since it was created. Like every year, I think, those are some cool new features. I like them that have been added, but none of them are nullable reference types. They're this is still my number one favorite. This is also kind of going back a few slides when I was talking about shifting left. This is also probably the number one thing that is hardest to deal with when you're thinking about some of your code, because it's a lot more work, unfortunately, that we have to deal with. Now, I do have a kind of a joke in there that this is not as hard as Rust. So if you've ever worked with Rust and you're used to like how that manages memory, then this is going to be easy. This is nothing compared to that. That's what I assume. Like I've only done a few tutorials with Rust, and I vaguely remember thinking, okay, yeah, that's hard. That's a lot. So if you're not familiar with nullable reference types, the idea is it is a flag we enable in the compiler, and now we're saying, hey, compiler, I'm going to add some special syntax, the question mark, in a bunch of places. If I add that, that variable might be null at that point in time. We're not sure. If it's not there, then that thing is not null. And why don't you, compiler, do some checks to make sure that what I've said is true within this code? And if the compiler can't verify that, then you get a warning, or you get an error if you enabled all your warnings as errors, right? So that's the idea behind it. So here's very basic code that is kind of showing this. So this code right here that we're looking at is if you are essentially if you're using this, right? So let's start with this method, some method. We're going to load a user ID. And so we're using nullable reference types, as you can see with the question mark. So what we're saying is, hey, this method, load user ID, it's going to receive an instance of HTTP context, and that thing might be null. We're not sure. We haven't checked yet, right? We need some kind of if statement to figure out if this is or is not null. So until then, the compiler, or until we need to use it, the compiler is just going to assume, all right, this might be null. I'll keep an eye out for that. We're also saying that the return is a string which might be null. So we might be a string, an empty string, or null, right? We're just keeping that in mind. So here we have our if statement. If the context, right? If this is null, then we're going to return a null value. Right? That's very common code, right? Otherwise, we know context is an object, right? It's an instance of something, and we'll return what we assume is a valid user ID of some sort. So that's this line. But notice that once this runs, this user ID variable, this could be a string, a valid string instance, or it could be null. And so when you get to this line right here, the second line, when you get to this line right here, we're trying to use the user ID in a spot where, well, now it's null, right? So we might get a null reference exception at that point in time. So that would essentially create the a compiler warning or error if you have your warnings as errors. Whoops. So let's actually look at some more code that's using that. So first of all, as I mentioned, if you want to go ahead and enable it, it's very simple. It's just another compiler flag. Go ahead and enable it. Very easy. So this application that we're looking at, it's a really simple ASP.NET application. It's something that'll receive like a rating and then just store that rating in a database. That's it. Very simple thing. So let's look at an endpoint over here. And okay, sorry, I want to apologize. I copy pasted the wrong application. I thought I grabbed the one that uses more traditional controllers. So unfortunately, this code might be a little different to you. This is using minimal endpoints. So I'm not saying you should definitely be using minimal endpoints. I think there's pros and cons to them versus controllers. I just need to call out. I'm sorry about that. I grabbed the one that's using just different looking code. But this is the endpoint. We're going to go ahead and get some ratings. Actually, you know what? Let's look at the other one. Let's look at post. If you're going to create a new rating, if you're going to pass something in, we're going to scroll down here. And so this class, this is actually the body, right? The input object of what we're going to go ahead and receive in a post request. And so the body itself, we're requiring some information, right? So the rating right here has, that has to be required. That's an integer. That's fine. But right here we have some comments, and we're saying, hey, these comments are optional. You don't have to give us these comments. Now, if I wanted to, copy pasted the wrong thing. Now, if I wanted to go ahead and add another thing, right? Let's say, some other value that is required is going to be like a display name, right? So, traditionally we would say, get, set, all that stuff. But right now we have our red squiggly marks, right? And that is non-nullable property must contain a value when exiting the constructor. What that's saying is, hey, you don't have a question mark here. You're not saying that this thing could be null. So you're telling me that within the code base, this thing is required to be not null. And so the compiler has checked it and said, well, I don't see anywhere where you're setting that, where you're requiring it, right? So two options: either actually require that this be passed in with your request, in which case you have to say required, and unfortunately, you also have to add the attribute. I'll talk about that in a second. So you can either add that, or you go back to saying, no, this actually is optional, and that's fine. And we'll keep track of that within the rest of our code. Anytime this variable is used, we have to know, like, if this is something that might be null at this point, we have to handle it, right? We have to have an if statement or something else. So I mentioned that if we're going to go ahead and require it, we do have to add the required keyword and also the required attribute. I think stuff like this is why a lot of people don't like the nullable reference stuff. The reason for that is because it's dependent on what creates the object. So this whole object right here, this is actually the request object to this endpoint within my minimal and API, right? This is what's actually passed in. And so the reason for the attribute is because we're not newing up an object. So what happens is, if let's say I get rid of that and I go up here to, let me copy paste that just so I don't have to type a bunch. So var AAA is new, that, and then I start setting variables, right? So display name is equal to AAA, rating is 1, etc., right? All of that stuff. There we go. So this, right here, we're newing it up. And so we can be required. So because I have said display name is required, right, we use the keyword. If I get rid of that, immediately we get some red squigglies saying, hey, you never set that display name property. But notice that this endpoint, we're not newing up an object, right? It's being deserialized. So unfortunately, that is why we have to have the attribute, because the attribute is telling the serializer, the JSON serializer in this case, hey, you need to make sure that field is required, right? We're going to go ahead and use reflection or whatever, all that fun stuff, to make a new object, and we're going to set those properties. So that's it. That's the annoying part about that. So if you were wondering why I had to say require twice, it was just for that. Once right here for newing up the object, and then once in the attribute for the serialization side of things. All right. So that's the null stuff. And you know what? Actually, we have a good sample right here. Within the endpoint, right, we have made the decision of, hey, at our interface level, something's sending us a message. They don't have to send us comments. However, within our code, we still want to use our comments. We want to, if we don't have a value, we're going to use an empty string. We're not going to use null, right? We've made that decision within our code. So right here at the start, we're just going to say whatever comments value we want to use, either an actual instance or an empty string. Either way, as long as it's not null. And so now whenever we pass our comments around to other methods, we know for an absolute fact that thing is not null. So like if I go over here and scroll to the right, no question mark. We are saying, for an absolute fact, this thing will not receive a null value. All right. I do want to mention quickly.
Hey, Al,
I'm
I have a
saying.
question.
Oh yeah. Oh, perfect. Yeah, go for it.
What is, I think, one of the areas where the nullable flag causes some frustration is when you're using kind of older original C# library functions that don't mostly with string handling. Things like string.format or string builder, things that are really pervasive and common, but that are not, their typing, their syntax isn't that it would accept a nullable string. It has to accept a non-nullable string. So how do you handle kind of the impedance mismatch of working back and forth from your newer code with nullable with strings that are kind of explicitly nullable with the question mark, and legacy strings which are implicitly nullable because that's how C# strings were originally defined?
Yeah, that kind of stuff is hard. That's actually really similar to what I was just about to mention, in that even though like the code that we're using right here, like everything I'm showing off in my demo code, this is all code that we own, that we control, right? We can update it whenever we want to. If you have, if you're going to be writing like some third party like NuGet package that you want other people to be able to use, you kind of still have to do those checks. So you can say, hey, I have, well, here, let's actually look at this method. So this is a public method. If I were to put something like this into a NuGet library that others can use, even though I'm saying comments is not null, right? Because in my code I've enabled the compiler flag, someone using it could be doing the opposite, right? They could be using the default, which means I don't want the nullable reference types checked, which means that I should, in my code, have that code where I'm saying, like if comments is null, blah blah blah, right? Throw an exception, whatever, or use the null reference exception handler to do that check for you, right? Stuff like that. That's this side of things. So I think you were asking about the opposite side, like, well, hey, what if I have a what if I'm calling some other method that has it, or that says, right, its method signature doesn't have any question marks. So by default, you kind of think like, okay, well, the compiler says, there's no question mark, so yeah, that can be an instance of an object, or it is assumed that it will only receive instances of an object. That one's, I haven't run into a lot of issues with that, to be honest, because usually that code has its own null checks, right? Because it was written with the assumption that anything passed in might already be or might be null, right? We don't have any special syntax for it. Really, what this is doing, what the special syntax is doing now, is just removing the need to have those if statements all over the place. So because of that, yeah, I haven't had to worry too much. I'm curious if you've had any specific issues, because nothing immediately comes to my mind for that. But the downside is, if you find something like that, you can wrap that in an if statement, right? Do your own checking somewhere else, and then you're fine after that, right? Which is exactly the code we would write anyway, even without without the nullable reference stuff enabled.
That's a great answer. And yeah, I guess where I was what happens for me sometimes is I have to pick which compiler warning I want to get. So if my newer code does not define the string as explicitly nullable with the question mark, then it works really great with the older code, but I get a compiler warning. Whereas if then I upgrade my typing to be newer, then I get a compiler warning wherever I use it that it's like not the right type. And it's almost like I'm thinking, like, should I do a weird typecast here to like define or create another variable, another copy of the string, which is the one that the function accepts, and copy the value in. And if I were to turn on like warnings or errors, then yeah, then I'd be really stuck. So then I end up putting in pragmas to ignore those errors. It's probably because I don't understand the feature fully. I mean, really, this is probably user error at the end of the day. But thank you. That was a really good answer. And I don't want to take you down a rabbit hole here. So thanks for the great response.
Yeah, no problem. Yeah, the thing about this feature alone is it can get complex, especially when you have newer code and older code, um, or if you're upgrading a repository. Like the thing I showed off was, hey, let's do this at the project level, so the entire project has this. Versus another thing you could do is you can enable it per file, and that is nullable enable. Yeah, there we go. Yeah, I remembered it somehow. Yeah, and so if you want to just go ahead and add this, per file, that's an option. That's something you can do. I personally don't like that because it just feels weird, like when you're knowingly adding, some code, in one spot versus another. Um, as in, like, hey, in this file, all of a sudden you can use those question marks to say something is null, or it might be null, right? But in another file where it's calling, it's not, and yeah. So I try to avoid it for that reason. I feel like that is too easy to get messy, but it is something people can use to slowly over time force themselves to upgrade to using this feature. So yeah, so let's go ahead and get back to the slides. After talking about all that for a while. So a couple of things I do just want to mention about it as a feature. The thing I like to do is I like to check at what I call the ingress of an app. So any kind of HTTP requests or anything coming into it, right? Like endpoints at your controller level, something like that, or anytime your application makes calls outside, right? So this can be database calls, custom HTTP requests you make, stuff like that. And so in theory, that means that you're doing all of your if checks at the edge of your application, and then internally, okay, we've checked everything, this, and the compiler has verified that, yes, we didn't forget anything, we have checked. And so we know everything here is not null, except in the handful of places where we are not sure, where it might actually be null. Bottom thing I do want to mention, personally, I find it easier to not have to have those checks everywhere, not have to have the extra syntax with that question mark. And so I like to require data by default. Now, obviously, this doesn't work for everything, everywhere. But I like to do things like that sample that I showed over here, right? Here we go. Where, okay, yeah, comments is not required per se, but at least having an instance of something is required, right? An empty string is a valid value in that case. So let's try to require not having a null value where possible, right? So yeah. All right, and last thing that I do want to mention about nullable reference types, they definitely do find bugs, and that is why I really like it. So when this feature first came out and I started adding it to a handful of personal projects that I maintain, I thought, oh, okay, I've been pretty good about this stuff. None of these are big projects. I don't think it'll find anything, but it'll be nice to throw this into some projects so that way I get some practice with this feature. And every single project, I found at least one bug. It's probably not something that I would have hit anytime soon. You definitely edge cases, but it definitely found, at least one, maybe a couple in others. There were some places where it forced me to think, right? We're doing that shift left thing, right? Like, oh, hey, it's possible that it actually is null here. Let me think about that, a level above, and then we're changing some code, which overall actually did help some of that architecture, that kind of stuff. So it is probably one of the hardest of these to really get into your code, or hardest probably isn't the right word. It's one of the most time consuming. Yeah, let's go with that, to really add to an existing code base. But I think it is worth it. I think using the feature like this really does help reduce a lot of those certain classes of bugs, right? Specifically, null reference exceptions. Mm-hmm. All right, cool. So that was null stuff. I always feel like I talk too much about null reference types. Like I said, I really like them. I think it's a great feature, but I'm not going to talk about it anymore. I apologize for probably talking too much about that. Let's move on to the next recommendation: static code analysis. So we've probably all seen something, right? Some form of static code analysis within, if not C#, somewhere else, right? You have two benefits to static code analysis, right? One of them is just checking for code issues, right? Like, I think one of the most common is like, hey, you said this class is disposable, but you never called dispose. Something like that, right? Another one is enforcing styling rules. So, as far as those things go, there traditionally within C# or .NET in general, we've had a lot of ways to actually add source or to go ahead and add that kind of static code analysis. Traditionally, it's all been install some tool, right? Some of them have been free, some of them you've had to pay for them. So, decent list right here: Sonar, Source, Cube, Cloud, etc. There's probably like 3 more other Sonar type ones that company makes: CodeMave, FXCop, etc. Right? Every developer has to have the right thing installed, maybe sometimes the same version, at least the same major version, right? All of that kind of stuff. And they're really helpful, right? It's nice, as a team, you probably get together, you decide, hey, we like most of these rules, but let's turn off a couple of them because either we just don't agree with it, or maybe it's showing up too many times in this type of application, stuff like that, right? So for a long time, that's kind of how that worked. And so back in 2010, 11, over a decade ago, Microsoft rewrote the compiler to C#. So when C# first came out, the compiler was written in C++ because that's the tool that they had at the time. Fast forward a decade, and C# at that time was very advanced, and they said, hey, you know what, we can get some stuff if we rewrite the compiler for C# in C#. And the name of that project was Project Roslyn. So the name Roslyn is kind of stuck around for reasons, specifically Roslyn analyzers. And so Roslyn analyzers is one of the really cool features built into the new Roslyn analyzer, or Roslyn compiler, which is basically static code analysis. It lets you write something, some code that'll run during the compilation process, when the compiler is going through the code to just look at the code, and also while it's doing the compilation process. So as far as Roslyn analyzers go, you have, well, as you can see on the slides, analyzers all over the place. You have some that are already built in to just C#, just by making a new project. They're there. They're already built in. You can add more using a NuGet package. There are a lot that exist. You can even build your own, right? By default, or the minimum thing that an analyzer does is look at your code, and it should check some kind of recommendation. But it can also fix your code if the analyzer includes some sort of code fix for you. So I mentioned that there are already a bunch of built-in ones. So here are essentially all of the ones the last time I checked. It's possible that there are more now, or at any point Microsoft could throw some more flags into the C# project file. Enable.NET analyzers. This is like, if you just want to turn them on, like this is the default one that you should be turning on. Enable.NET analyzers, as I called out right here. If you're familiar with FXCop, essentially this is FXCop just now built in as Roslyn analyzers. There are a handful of other analyzers depending on what you're using. So if you have like a ASP.NET application and you're using Open API, some analyzers to just make sure you're doing some specific things, setting certain properties, etc., etc. These bottom two are specific to things like AOT. So, for example, if you're using ahead of time compilation for a project and you want to make sure you didn't add some code that does use reflection, right? Because AOT does not have reflection enabled. Like, that's one of the things that makes it faster, is pulling out all of that code. But the downside is now there's going to be a lot more work that we as developers have to do. So that is a big downside to AOT. But if you want something there to kind of help double check that you didn't do something that will definitely mess with you later and cause you to rewrite a bunch of stuff, these are some that you want to enable. But at a minimum, I tend to just enable these first two, and that gets me pretty far with the built-in ones. So again, that's just already built in for you. And I can show you the demo code over here, right? It's exactly what I said, right? Enable net analyzers and enforce code style in the build. So got those two. Now, as far as adding more, they can show up in any NuGet package. So you've probably seen some, whatever analyzers packages in, when you just go in to add NuGet stuff. There are a ton. I'm only listing a handful right here. And I do want to mention that this is just a naming convention. It does not have to have the word analyzers somewhere. For example, this bottom one right here. So that's just how people create those packages. So these are packages that just have those Roslyn analyzers. They're checking your code for anything. One of the things I really like is down here, this bottom one, sonaranalyzer.c#. So, when I go back a few slides and I was talking about, hey, here's this tool that you install that has that you have to pay for in the past. Well, Sonar, I don't know what the name of the company is. It's probably Sonar Company or something. But they have gone and made all of their analyzers as Roslyn analyzers, and you can just go and install them for free. Now the downside to that is you don't get the other features that they have. Like, you still have to pay for those, and those are features like, hey, let's declare bankruptcy. All of those issues that currently exist in our code, let's ignore them. Just tell me about the new ones, right? Like, that's not an option that you get with a NuGet package. But if you just want to go ahead and add them to your project, yeah, you can go ahead and do that. It's just adding a NuGet package, right, for any of these. You can go, to NuGet.org, just search analyzers. You'll see a ton. You'll get a lot of options for things, and maybe some of them you'll even agree with. I'm sure there are a lot you probably disagree with. There are a lot I know I disagree with. I definitely modify a lot of these rules when they come in. And so, speaking of rules, static analysis rules, the other recommendation very much related to this is manage them all in a single place. And so that is with an .editorconfig file. So I'm actually going to go back a bunch of slides. I don't normally do this. I don't know why I'm going back slides. But I was talking about, in the past, you would have to install different things onto your machine, right? Every developer on the team had to have the same install. You probably had the guide, day one, you're a new developer on the team, or your laptop died, you got a new one, right? Here's the guide of everything you need to make sure you have installed, so that way we're all checking in code using the same set of rules. And there are benefits to that, but the downside is, yes, you all have to have that installed, but also you have rules in a bunch of different places, right? All the Sonar rules are different rules from CodeMade, FXCop, specifically, writer, resharp, revisions, etc., right? They're all managed differently, probably in a file stored on your machine somewhere. Maybe you can check that file into source control. That would be cool, right? But that's still something you have to deal with, because a lot of those rules are maybe machine-wide, stuff like that, right? Some tools were able to go specifically per repo, which was nice, but not all of them. And it would be a hassle if you had more than one of these installed, which is why I usually didn't see people installing more than one, just because it would be a hassle. But back here, when I'm talking about managing all these rules in one place, because of Roslyn analyzers, now it's built in at the compiler level. Another cool feature we got is support for editor config files. So if you're not familiar with .editor config files, it's this open standard thing. Different programming languages have different levels of support for using this file. If you care to look online, editorconfig.org is good. Good spot that kind of talks about it, really goes through like, oh, here are the things you could do with the file. Thankfully, the C# support is really good, and so here's a sample file of just kind of what it looks like. So we're saying, hey, this is this editor config file is going to work for C# files. Like, here are the rules. Notice the first couple of lines right here. We're talking about the indentation. So if you are a spaces person, someone else is a tabs person, doesn't matter. It's checked into source control. Everything here is going to be spaces or tabs. As a team, you've decided, so now you don't have one person on the team breaking everything for someone else. So you have, spacing and that kind of styling set of rules. You also have a bunch of C# rules that are just kind of built in, right? Because these are just strings, and the compiler knows to look these up, right? So if you want to say, if you want to require parentheses around, math or any addition, that kind of stuff, you can say it's always required, and if someone's missing it, we're gonna force it's an error. If for some reason on your team you really don't like it, you can make it silent or a suggestion or something else, right? So this file is what you use to specify the rules of compiler warnings, errors, etc. So Rosalind is going to go ahead and look at this and use those. So you know what? Let's go back over here. So this solution right here has a .editor config already. We'll go ahead and look at this. So it's a little bit bigger than that sample. So I did mention the .NET specifically built-in ones, but I'm going to go ahead and scroll all the way down here, and here we go. So we have some called .NET Diagnostic, S2325, or SA1403. So let's look some of these up. So let me start with this first one, CS15. So C#, that. And we see, here we go. So here's some Microsoft documentation on this one. So I'm assuming that because we have some documentation on the Microsoft site, this is one of the things built into the language, right? The C# itself is telling me, hey, this is a warning. So let's go ahead and scroll down this S to, whatever, right? So C#, let's paste that one. And here we go. I was hoping to find official documentation, but just looking at this, you can see, hey, this is on Sonar Sources side, right? S2. So let me see if I can find another one, a better one than that. So C# that. All right, fine. I know this is a Sonar one. Here we go. No, okay. Great. I need to choose one. Anyway, you can see, just based on my searches, this is a Sonar.NET one, right? And then I can grab another one over here, SA, and search for this one. And notice, here we go, finally, one that's actually some documentation. Here's some documentation around style cop analyzers. So what we're showing here is this one file is now controlling the rules for different static code analyzers within our project, right? So we have a couple of these enabled, right? So we have Sonar Analyzer, NuGet package. We have the .NET analyzers enabled within our project, and now separately we have this file specifying, rules for each of those. So, and these are overrides, right? By default, those rules are still going to do whatever they want. But if we want to say, hey, for this specific rule that I have to look up every time because I don't memorize any of those numbers, we're going to say that yes, that one definitely should be an error. Or down here we could just say, hey, it's a suggestion. I know. Maybe, hey, make my editor remind me that maybe that's an option, and depending on my mood, maybe I'll change it, right? That's the suggestion there. So, so that's the big thing with the .editor config file. So now you have that checked into source control, and now everyone by default just has that built in. So that means that I, on a Windows machine using Visual Studio, have the same rules as my other partner on the team who is running Writer on Windows versus someone else on the team who's running VS Code on a Mac, right? We all have the same set of rules, and we don't have to install some extension to force us to make sure we don't accidentally check in some code that fails some of these rules. All right, let's close a bunch of tabs. Hey, there we are. All right, cool. Now, other things as far as suppression goes is that there are other ways you can suppress some rules, right? So I was talking about specifically in this file because that's kind of the global thing, right, within your repo at least. But if you want to suppress some other rules in a different way, you have some other options, right? So there's a global file or there's an attribute. And so as an example, I can go to here. Let's go over here. I can say something like, yeah, here, let's, for a equals new view, and let's go ahead and set some values. Count equals 5. There we go. All right. You know what? This is good enough. I didn't actually need to make any changes down here. So here we go. We're getting a compiler error saying, "Hey, you're not using this local variable. You stored it, but you know, maybe in my case, I actually want to do something with it. Actually, you know what? Here's a better example. Here's one that I do all the time. Not this exact case, but something where, hey, you know, you're not doing anything with the return value. Now, in this case, right now, um, in this code, we probably should do something. But let's say that you're in something like a builder, right? It's ASP.NET application. You're registering a bunch of services, which, now that I think about it, that might be exactly what I'm doing over here. All right. It is, but I don't have that enabled here. Okay, anyway, we'll go with this. We'll go with this set of code right here. So let's say that I think I have a valid reason for choosing to ignore it. Now I can go ahead and, which one? Nope. Here we go. So I can go ahead and just suppress it in a bunch of different ways. Simple one is just adding a comment around it. I'm just I'm using all right. None of these were the one that I wanted. Sorry. But you know, that's why I had, you know, all of these show up, right? We have 3, I guess 4 in total, right? We can just keep suppressing them with comments until we finally get everything. Hey, there we go. Now we can compile. Cool. This is kind of ugly. This is not the best way to do this. But again, it all depends on how you want to you know, deal with your code. Let me get rid of that. The other thing that I mentioned is an attribute. So let's go to this one. Let's call it, there we go. So we have this attribute added to the method, and let me go ahead and this justification. There we go. So this attribute is going to go ahead and ignore this one. Specifically S1848. You probably remember we still had like 3 more. I'm not going to go through and add an attribute for all 3 of those. When this happens, you should definitely put some kind of justification, right? You know, what's the reason we're choosing to ignore that? I'm going back and forth on whether I like this one more or the other option, the very last option to ignore it within our code, which is to ignore it in a suppression file. So this went and created a new file over here called global suppression. Let me zoom in over here. So global suppressions was created, and it's just like that attribute that we had before, where you know, we have our justification and all that. Now, because this is in a different file, we are specifying where to ignore that, right? So in this case, we're saying specifically a method. So this is just like if this attribute was added above the method, like we saw. If you want to say something like namespace and descendants, I may have misspelled that, but you can say something like this, and so this will be, you know, the whole namespace and anything below it, stuff like that. And that's just, you know, it depends on how you choose to organize these things. So in my projects, I'll usually have the bulk of my, you know, rules that I care about within the .editorconfig file. And every so often there are some where I just kind of choose to ignore them, maybe in a single file or a certain namespace, just because it makes sense to do that, right? You know, again, we're all humans, we're adults, we understand that you don't have to follow these very specific rules in every specific instance. And so, you know, I think as long as you have valid justifications, everyone on the team agrees, just use whichever one of these works for you. So let's see. Yeah, and that's it. That's everything involving ignoring certain rules. Suppressing those rules within your application. So, all right. So I guess we have the next recommendation. Before I do that, anyone watching? Any questions, comments, concerns, insults? I usually prefer to if you wait on the insults until the end, just because it might throw me off. But you can. I'm not going to stop you. All right, it's quiet, so I guess I'll move on. Cool. So next recommendation. I don't have a lot to show off as an example for this one, but it is codify your code patterns. So it's very common, I think, for all of us as developers to have some kind of or end up with some kind of pattern within our applications that we always follow because hey, this is this is uniformal code. This is something where we have to do it this way, otherwise an error happens. So then we have to add error handling and checks, right? Like maybe it's something like, okay, I need to set a property over here, and then I can go ahead and call this method, and then ABC whatever else afterwards, right? Something like that. And so we have to remember that, otherwise something goes wrong at runtime. And we can check that stuff with PRs, right? You have a pull request that goes into your main branch, and then someone else has to verify that, which is great. That part's good, but we're human. We forget. We make mistakes. And so that's why this recommendation is to codify your code patterns, right? Write code to enforce those patterns. So one of those patterns one of the ways to do that is using a Roslyn analyzer. So you can go ahead and create a custom Roslyn analyzer to check your code to kind of enforce that. So the example that I put right here is, personally, I like having a Roslyn analyzer, personally, I like my endpoints to require specifying what the auth is required for that endpoint, right? So you either say you must be logged in, authorized, or allow anonymous. I know it's common to just kind of set something site-wide, and then maybe our ASP.NET application is mostly authorized. You have to be logged in to access 99% of the endpoints, but here's 5 endpoints over here that are anonymous, and so we'll just go ahead and add those 5. But personally, I don't like that I might have missed one, right? That maybe I accidentally set one to anonymous that shouldn't be, right? Something to that effect. And so if we have an analyzer to check that, then cool. We at least check that, hey, we have our attributes set everywhere, right? Or because, hey, what if I did the opposite? What if I said allow anonymous for all of them except these 5 that do require authorization, but I missed one? That would be really bad, because now anyone has admin functionality for this one endpoint, right? That's the kind of thing that we would want to check for. So that is something that you can do. This is actually one that I've created. I have made one. I did recently find a bug in it, so I will work on that at some point. But this is a Roslyn analyzer. It just scans your endpoints, and it requires an attribute, or in the case of minimal endpoints, there is a method call for that. Another thing that you can do is create a source generator. So source generators have been around for a couple of years at this point within C#, and so this is writing code where at compile time, it's going to go ahead and generate a bunch of other code. So this is used heavily already by the .NET team. Like, even though it's only a couple years old, it's used heavily for a lot of AOT stuff because you don't have reflection, right? So you need to generate a bunch of code at compile time. So an example of something you could do with source code generation is let's say you have the example where you have some sort of class and it has an interface. And honestly, I don't know about you, but in my case, I write a ton of interfaces just to make unit tests easier, right? Like I want to unit test something else, so let me mock out that thing in an interface, and then it makes my life a lot easier, right? I don't have to do a bunch of other setup work. And so if you have that instance where this interface exists just so you can unit test it, then why not have a source generator automatically generate the interface based on the concrete class, because this is what we actually care about, right? And then you don't end up with that case where you modify, like, oh, let me add a new parameter to the method, and then compile. Oh, it failed to compile because I didn't add it to the interface. That loses 10 seconds, but it's still annoying. It's still a thing you don't want to deal with. And so you could end up with some code where this is your actual code base, right? Where you add some kind of attribute, it generates that code at compile time, based off of code scanning, and then you never have to care about what's actually in the interface. So that one is actually something that I have. Let me actually delete this file because I'm scared it doesn't build right now. It still doesn't build. Okay, perfect. So,
Hey, Al, we got a question in the chat as well.
Okay, yeah. All right, so we have a question. What are AOT and IOC? Okay. So, give me 1 second. I'll answer that question. Let me just finish showing this part off. So as far as the the interface goes, right? So I can go ahead and I can delete this one right here, the ratings repository, and I can go ahead and add the generate interface attribute. Now, I do need to add a NuGet package. I forgot to do that ahead of time. I'm sorry. So this is one I created, so I'm just going to go ahead and search my name. Oh, hey, there it is. Public interface generator. And it is going to be the one that's newer. I forgot to... Oh, no, those are two different ones. Oh, that's my fault. I'm sorry. I have similar naming, and I think I need to delist one of them. So sorry about that. All right, so let's add the using statement. Using... Yep. Now, dot source generators, dot public generator, dot attributes. There we go. So now we have a attribute here, and notice that now we have an interface. So I can hit F12. I can go to the definition for this code. This is the code generated at compile time from the source generator. It's a little bit more verbose because for simplicity, it was easier to not throw these using statements up. But this is exactly what the concrete class is. And so if I decide to all of a sudden add some new method, public void, whatever, and then, fine, let's write something out, etc. There we go. I can hit, Control-Shift build. The build has started. It's looking good. Cool. I can go back to the definition, and there we go. Automatically, it's there. Void, whatever, right? So that's the benefit of it, in that it's just one less thing that as a developer we have to do. One less thing we have to worry about. Let's be a little bit more explicit about some of the things that we do. All right, so back to the question. So what the question was, what are AOT and IOC? All right, so I'll start with AOT. So just two acronyms that are completely different. So AOT is ahead of time compilation. So if you're familiar with the compilation process for C# or .NET in general, you hit that build, and then it creates DLLs and executable files, and those are compiled like halfway, right? So you know how you can take your .NET DLL and it runs on a Windows x64 or x86 or ARM or Mac x64 or Linux x64, etc., right? Like all of these combinations. The reason for that is because when it was compiled, it went into this intermediary language. I don't know if it is called MSIO, Microsoft Intermediary Language, or maybe it has a different name. I forget. But when your application starts up, it detects where it's running. It says, "Oh, I'm on Windows on ARM." So I'm going to take the intermediate language and I'm going to compile it to the actual instructions that run on an ARM CPU. And so it does that kind of piecemeal. Like it says, oh, hey, well, I'm using this class and this class and this class right now. I'll compile those. If you have a class that's never used, never gets compiled, right? Stuff like that. And so ahead of time compilation is the process where you say, okay, I'm going to compile my application specifically to run on Windows on ARM. And so it does the whole compilation. It skips that intermediate language step, and it goes directly to a compiled DLL that will only run on Windows on ARM. And so that is AOT. Now, there are pros and cons to doing that. The pros are it has a better startup performance. So that means that because it's not doing that compilation step, right, of going from that intermediate language to the native CPU instructions, it just skips over that completely. So that means it starts up faster. Depending on the application, it could be uh, it could be a smaller binary. It actually could be a bigger binary too. It depends. Blazor, I know you can do Blazor WASM. That ends up being like double the size. For non-Blazor, I'm not sure. I know it depends, but I know that with AOT you can get your binaries to be way smaller, which is cool, right? I've heard about that. Being like, hey, that means that you can compile your application, put it into a container, and now your container starts up, very quickly compared to others, right? By very quickly, I mean, less than a second versus a second and a half, right? Like that's the difference, I guess. Something to that effect. I'm making up numbers. I don't know. But that's AOT. And one of the other things I did mention earlier, it doesn't have reflection, just kind of built in. Like that's a default because that reflection, it kind of comes from all of that intermediary language. Just so because that feature is gone, all of a sudden you lose reflection. So that's why I have this slide over here mentioning that the .NET team uses it heavily for AOT, because if you're going to have no reflection, but you still want to be able to serialize or deserialize JSON stuff, you still need something for that. And so that's where they're using source generators for, to at compile time generate some code that will generate your JSON for you based off of the class without using reflection. All right, I hope I answered that well. Sorry, I was not really prepared for that. So that's AOT. The other one, IOC, inversion of control. And so that is essentially, how at the start of your something like ASP.NET application or whatever, you start registering objects. You say, hey, I'm going to register this interface for this class. So whenever someone wants an interface, give it an instance of this class. And so if I go to my let's look post, here we go. To this post, inversion of control, we're passing in like an instance of this object, right? This iRating service. But because we registered it over here, iRating service, because we registered it over here, when .NET creates an instance of this object, of this method to invoke my endpoint, it's going to pass in that interface, which is a newed up instance of rating service. So that's inversion of control. It's just registering something in a spot to say, when I need this interface, give me this thing, or specifically when I need this thing, give me this other thing, right? It doesn't have to be an interface. It can be, I think keyed registration is coming up. So like names, like you give it a string. I don't remember if that's coming in .NET 10 or if that came out with .NET 9. But either way, other things, right? Stuff like that. So yep, and that's so that's AOT and IOC. So hopefully I answered that well. If not, I don't know. Like I said, social media. You can ask me there. All right. Cool. All right. So that was that one. All right. Cool. So we're down to just the last handful of recommendations left. These will go pretty quick. So next one, secure your software supply chain. And by what I mean by that is update your dependencies. So you have some application or applications that you work on. Do you know the last time you updated your NuGet packages? Because I've worked at a lot of places. We did not. We had no idea. I think we updated them when we remembered to look at that screen. So that can be bad, right? That can be an actual security issue. Nowadays, when you start up your application in Visual Studio, I don't know about others like Writer, but I know Visual Studio will tell you, like, hey, there is a known security vulnerability in this NuGet package. You should probably update it, which is great. I love that it's doing that, but we can go a step further. We can add some stuff to our C# project to say, hey, when I compile, just go ahead and audit all of my NuGet packages and do it for a specific level. So I think Visual Studio is only showing the bad ones, but if you want to say, yeah, every level, right, low, medium, high, or if you want to say medium or higher, right, that this is what you would go ahead and set them up. So I can, oh no, I don't have that enabled in here. All right, I'm sorry. All right, well, we'll just use this one, this example. So, this one, NuGet audit, that's the flag, true or false. Is it going to go ahead and enable it or not? And then the, audit mode or audit level are the other the other flags you can set up. So Microsoft has a decent or a pretty good, not decent, good documentation talking about these flags and how you set them up. The benefit of this is now when you compile, it'll just tell you, hey, you have to update this. The downside is, I mean, yeah, it could be another thing that could slow you down later down when you're doing development, because all of a sudden, hey, you didn't plan to have to update a bunch of NuGets and then test things, and now, hey, there's your Tuesday afternoon. So that is a downside to this. But if that happens, just make it just the high ones. You don't have to go with the low level for that. All right, next recommendation. I'm just going to say use .NET Aspire. I really like it. I assume you've seen it because Microsoft has been hyping it for years, or a year and a half, ever since it first came out. So I can't remember exactly. But if this is Microsoft trying to set up a good bit of success, so it just sets up some nice defaults for things, and it has one of my other favorite things, OpenTelemetry. So just by default, it says, hey, let's push you to using that instead of writing log messages for everything. If you're not familiar with OpenTelemetry, I'm not really going to go into it because I can talk on that for too long. But it's a nice thing to use. I like it much more than writing logs out. So, and then this is the very final recommendation. Just the last thing that I wanted to say is, if possible, use continuous testing, right? So use a tool that will automatically run all of your unit tests for you. I have a list of them right here. Remember earlier when I started and I said everything is free except for one thing? This is it. This slide is the one where you probably have to pay for it. So NCrunch is a tool I really like. I pay for a personal license for this one just because I like it more than the others that I've seen. ReSharper, Writer, Visual Studio, they all have something built in, but you have to have like a certain license for it. I know Visual Studio, it's the enterprise license, right? It's the highest one. ReSharper, Writer, same thing. They have like certain licenses to other C# level versions of the product. So it's not just Writer, it's Writer and something else. But the free version would be using .NET Watch. So you pull up your terminal and you type .NET Watch on your C# project and something for the tests. I forget exactly what the order is. There's a specific line. You can look it up. But this will continuously run every time you compile your app. It'll go ahead and run your application. It'll go ahead and run the compilation and then all of your tests. But I prefer something like NCrunch or the others because it'll just do that for me. I don't have to start up some CLI project, and it has something built in to the UI to show you what's going on. So for example, let's see, I think I had this over here. Yeah, here we go. So you see, all the green dots over here on the left-hand side. Those are because of NCrunch. Actually, in the bottom right section over here, this is a little progress bar within NCrunch to show that off. So I can go ahead, go to my tests, and I can say, let's say, hey, this result, and then false dot should be true. Oops, true. There we go. So now all of a sudden, hey, I just typed out some code. And now I immediately know, hey, some unit tests have failed. I did not have to wait to remember to click the button or, when I uploaded it, right, to CI/CD pipeline. So all of that stuff. So definitely a great feature. I really like that one. So I always try to convince people to use it. So in summary, in review, here's everything, right? Treat your warnings as errors, use nullable reference types, codify any coding patterns, secure your supply chain, and when possible, try to use continuous testing. And that's everything, right? Like I said at the beginning, use the things that make sense to you, right? Maybe try them out, see if you like them. If you don't like them, you don't have to use them. I'm not going to be looking over your shoulder. I don't have time for that, or know where you're typing code. The other thing I do want to call out, I've recently, within the past month, I've started making some YouTube videos, just going through all these very opinionated things that I have, and basically this entire talk is going into these videos. So these videos are starting a new application and writing out the code for it using using these all of these recommendations here. I'm not done with it. I'm probably about halfway through as of today. But if you just go to my site, programmerl.com, or if you just click on either of these two links, they show up there. So lastly, here's my info. Again, just search Programmer Al or go to my site, programmeral.com. I have a bunch of links to socials, etc., all that stuff. Whew. Okay, and that's everything. Now, I do see in the chat there were some questions that I missed, so I'll go ahead and try to answer them right now. Let's see. So the first one I see, is it bad to admit I don't update them unless I get that vulnerability warning in VS? Oh, so you're talking about the NuGet packages. That's not bad.
Correct.
That's normal. I think that's common. That's what we all do, right? Yeah, and that's why I started adding that flag as a reminder, right? So my day job, I work at a medical devices company. I'm on the cloud services side, so not on the device. So because we're a regulated industry, we have to follow, a lot more processes for like testing our code, making sure we do proper validation checks, all that kind of stuff. And so on our team, we have our CI/CD process check all of those NuGet packages, make sure things are good. Setting up the software bomb, right? The bill of materials. Some other team has gone and set that up, and they audit that every so often to make sure we're not shipping something that has known vulnerabilities. But a thing that we've done on our team on the development side has been, let's go ahead and enable those flags for those NuGet packages so we don't even make it that far, right? Like we're told on our side, instead of finding out a month down the line that, hey, there's this vulnerability that's patched and now we have to maybe make a hot fix or something that gets deployed. So that's the big benefit of that, of let's do that work now so like these other teams don't even know about us, right? We can complain about other stuff to them, and they deal with those problems instead of whining at us about updating things, right?
Yeah, sure. Yeah, in my case, the organization I'm with, we are rather limited on QA testers. So, yeah, I try to be mindful about not changing too much, knowing that we're going to need to have that tested, and I don't want to throw a whole bunch of stuff on their plate that they don't have room for anyway.
Yeah, that's fair. Yeah, that is the downside, right? Anytime we make changes to our code, it has to get tested. All of those packages that we can sometimes willy-nilly add or not, right? Anytime we change that's code that's changed. We didn't change the code, but we changed the reference. So yeah, no, that's fair. Not updating for that reason. All right, cool. I do see another question. What do you recommend for continuous testing for Writer? So Writer does have its own built-in. I forget what it's called. I'm just going to search that. Writer continuous testing. Let's see. Use continuous testing. Perfect. So they have something built in. This is the documentation for how to enable it. But you do have to have a license, and I forget what it's called. Let's see. Is it on here? No, you're not going to tell me here. Ah, darn it. Okay. License, no. Here we go. .cover. There we go. You have to have a license to .cover, and that'll be built in. And I think ncrunch.net is that. I go to the download. Okay, yeah. Ncrunch also has an extension in JetBrains Writer on Windows in beta. So that is, honestly, that one's my favorite. I really like it. I've been using it for just over a decade at this point. So I guess I've been paying for that one for a while. But those are my two favorite. If you're not able to use ncrunch just because Windows only beta, etc. Right? It's still early. Then yeah, I get that. JetBrains, writers.cover. I've used this in the past. I like it. It's good. When I use writer and I'm not able to use ncrunch, then yeah, just this is good. Otherwise, if you can't use either of those two features, then the other option is like I said, you're going to go ahead and .NET Watch, which, gonna be honest, I say use it. I don't. I don't use it. I would just forget every single time, and I would hope that I would remember to at least click that button to run the tests before committing my code. Just because that one feels like it's a bit of a hassle. I don't get the UI in my IDE, right? Like these green dots telling me the tests are passing or failing, right? I have to remember to look at the CLI for this. So yeah, so that's it. All right, cool. Let's see. Oh, cool. Now I look at the messages. So you're saying you do have dot cover. So awesome, cool. Alrighty. Anyone else? Any other questions, comments, concerns, insults? Now would be a good time for the insults. That I think that's fair because I'll sign off soon and I can go cry somewhere else.
Yeah, this is Joe. No insults, unfortunately, but sorry about that. I wonder in your C# research and experience, have you run across a tool that really easily will list out just all the methods in an application, kind of organized by the classes they're in, right? Just like basically just the headers of all the methods, because a lot of times I just want to know, hey, have I already written something like this or not? And it seems like it's such an obvious thing that everyone would want, so I'm missing something really obvious and I don't know what it is.
I have not. I see in the chat window right here, Codex.
Okay.
So I don't know how to search for that because I get the feeling that's going to be a different name. Codex. I don't know, C# maybe. I'm not sure. Rich, you put that, yeah. If you know the link, sure. Oh, Codex from ChatGPT. Oh, okay. Oh, God. All right, cool. All right. Oh, so this will can go ahead and scan your code. All right, that sounds really cool. I like that concept. The other thing I can think of, I know Visual Studio has, let's see, or was it? I've always accidentally gotten to it. I don't remember how. Let's see if I hit F4. Is that? Nope, that's definitely not it. Yeah, I'm not sure. One thing is a decompiler, right? I've used decompilers before, but that's on the DLL. That's not going to be like on the code itself.
You mentioned the Roslyn analyzers, and it just seems like it'd be a relatively simple application and using a Roslyn analyzer to basically print out a tree structure list of all your methods, and I've not run across it, and I'm just kind of surprised by that.
Yeah, so that wouldn't be great specifically on the Roslyn analyzer side because the analyzer runs every time you compile, and so if you want to output that every time you compile, then sure. But that would probably be like a better, like a separate tool, still using the Roslyn API to scan your code. That's probably like a from a user or use case perspective, maybe something like that. But yeah, no, you're right. That as far as writing that code, that would be straightforward because the Roslyn code can go ahead and scan your entire application, for everything that's in there, right? The compiler knows all that; it has all that information.
And semantically, so you don't have to parse code and figure out what's what. It's just there in the tree, right?
Yes, yeah. I don't know if you've ever looked at those APIs. It's like one step above parsing that, like, you don't have to worry about the white space, but yeah, you can see like constructor, and then you see the the individual input parameters and stuff like that. So it's not like reflection code is easier, I think, than Roslyn, but it's still better than having to parse all this yourself.
Correct.
Right? If you're gonna just like, here's the file, find all the methods, like, yeah, those Roslyn APIs are still way better than having to do all that yourself. Yeah.
Okay.
Yeah, I just want to give that warning to anyone out there, because the first time that I sat down to write any of that stuff, it took me way too long to even get started.
Okay, well, if
That stuff,
someone's
yeah.
looking for their first open source tool to make them famous, I think that might be an idea.
Yeah, there you go. That'd be perfect. Yeah. Cool. All right. Oh, and I see another comment in the chat. Looks like Gemini can also do that. All right, cool. I'm guessing maybe any of the AI tools out there that you can submit code to probably can do something like that.
Yeah, my hesitation is at that point I have to share my code. If I had something running locally, I wouldn't have to share my code.
All right, I'm not signed into Copilot. Can I sign up for free? Wondering if I could just ask it right now. All right, this is taking a second. You can tell I don't use a lot of these tools, but okay.
Okay, there's
All
your
right,
list.
there's a list. I don't know how much I like it.
Mm-hmm.
It's probably not that readable, but yeah, okay, yeah, exactly. And like you said, right? If you don't really like the AI tools, that's fair. Yeah.
Mm-hmm.
All right.
Okay.
Cool. All right. Sweet. All right. Anyone else? All right. I guess not. Cool.
All right, thank you, Al. That was wonderful. I did drop a link in the chat, and it's pinned for the survey. So if everyone would please take a moment and fill that out. As a reminder, all of the feedback we receive is completely anonymous. We want to know how well we're doing as an organization. And Al, I will send you a copy of the results as well. So.
Oh, thank you.
All right, sounds like we're all set then. Thank you very much, everybody. Have a great rest of your day.